Okay, so to warm up, I am going to give you, let's do the 5-minute rule. I'll give you 5 minutes to get this one done. Okay? All right, let's work our steps. Step number 1 says what? Find the domain. So how do I find the domain? Denominator equal to 0. Agree with that? Okay. So my domain here is all real numbers, but x cannot be equal to 1. Agree. Step 1.5. What does step 1.5 tell us? Factor the numerator and factor the denominator, right? So this becomes x plus 5 and x minus 1. This becomes 4 and x minus 1. Agree. What's wrong with that?
X will end up equaling 1.
But they both have an x minus 1 in it, right?
Yeah.
Okay. So that's gone, which means my new function is this. Agree. So that's what I go off of now for the remainder of my problem. What's the vertical asymptote of my new function? What's the vertical asymptote of my new function? Nothing. None. There isn't one. 4 can't equal 0. Four does not equal 0. So there is no vertical asymptote. Step 2. Horizontal asymptote. What's the degree of the top?
1.
1. Degree of the bottom?
No.
0. So I'm in a top is bigger case, which means what? There is no horizontal asymptote either. Okay. Step number 3 says what? How do I find my y-intercept? Plug in 0 for x. Zero plus 5. 5 divided by 4. A little bit more than 1, right? 1.25. Okay. Step number 4. How do I find my x-intercept? Set the numerator equal to 0. Again, you all have this written down. There's 23 of you in this room. When I ask you that question, 23 of you should be able to go like this with your eyes. The next step is we find the x-intercept. It's literally on the page with you right now. Correct? Bailey, what did I tell you? To participate, because it's going to make life be easier, right? Okay? Crack your shells, people. Okay? It's time for you to be born as a new student. Okay? Crack it. Let's go. Start participating. Okay? X-intercept. How do I find the x-intercept? 23 voices all in one. There we go. Numerator equal to 0. X plus 5 equals 0. X equals negative 5. So my x-intercept is -5, comma 0. 1, 2, 3, 4, and 5. Next step. Find the hole. How do I find the hole? Nope. Whatever I factored out, I set equal to 0. Oops, tap the brakes. I don't want that. I just want that. Okay. So I have my hole. So what did I factor out? So x is equal to 1. So my hole is at 1 comma something. How do I find that something? I plug that into my new function. We seem to have lost 22 voices. 1 plus 5. 6 divided by 4. 3 halves, right? 1.5, right? Okay. So my hole is at 1 comma 3 halves. Right? So on my graph, I literally go to that point and I put a big old hole. Do I fill in my hole ever? Never, ever, never. Okay. Now what? T-chart, right? Do I need a T-chart in this one? What kind of a function is this? It's what? It's linear. It's a line. Okay? It's a line. If I rewrote this as x over 4 plus 5 over 4, what would the y-intercept be? 5/4, right? What would the slope be? What would the slope of this line be? Slope of this line. To make us not have to do a T-chart. One over what? Nope. You had me at 1 over. Slope of this line. Let me rewrite it a different way. What's the slope of this line? 1/4. Okay. What does that mean? I'm not familiar with over. Up 1, right 4. So if I go up 1 from here, write 1, 2, 3, and 4, because that was an actual point, I should be right there. If I go up 1, I'd go right 4, 2, and 4. Up 1, right 4. Up 1, right 4. What if I don't like going up and right? Down and left. Okay. All of those black dots we could have used as points in our T-chart. Okay. If you didn't see that it was a line, that's fine, but you could have done those as your points. Then we need to, I'm going to start at my hole because that's just how my arrows work. We make sure we don't fill in our hole. Okay? All right. Brand new day. And we get to talk about a brand new topic for most of you. Okay? So, when determining the horizontal asymptotes, so that's what? Where do I determine horizontal asymptotes? Which step? Step 2. Step 2 is my horizontal asymptote step. So in step 2, we compare the degree of the numerator to the degree of the denominator. Yes? Okay. What are my 3 options? Top is bigger. We also called that big over small, right? What's the horizontal asymptote there? None. Another option. What's the horizontal asymptote there?
Y equals 0.
Again, 23 voices. We are literally just going through step number 2. We've been doing it for 2.5 weeks now. Okay? What's my third choice? And what's the horizontal asymptote there? Somebody other than Jenna, where do I get A? Where do I get B? Dude? Of the top and the bottom. A is the lead coefficient of the numerator. B is the lead coefficient of the bottom. Yep, love it. Okay? Okay? So those right 2, those are locked in. You have a horizontal asymptote there. I'm not changing that whatsoever. Okay? However, what today changes is today changes this case. Okay? So when we are in a top is bigger case, we have one more check. Or one more step to do. Okay? And that's going to be step number 6. We're going to do step number 6. If the degree of the numerator is 1 degree bigger than the denominator. After we've done common factors. So we have to have done step 1.5 first. We factored everything out. And the degree of the top is 1 bigger than the degree of the bottom. We get something, in that case, called a slant asymptote. Okay? So we're going to take that horizontal asymptote and we're going to tweak it just a little bit. So it's going to become, it's not going to go all the way to vertical. Okay? It's going to be on a tilt. Okay? We're going to tip that horizontal asymptote just a little bit. Okay? And here's how we do it. Okay? So, first off, there you go, P. Yep. Okay. So, we've got a function on top, we've got a function on the bottom. Okay? The first thing that I am going to do is I am going to figure out what the top divided by the bottom is. I'm actually going to do that division. Now, the nice thing is we have synthetic division. I can use synthetic division if the denominator's degree Actually, I'll even make it even easier. The denominator's degree has to be 1, but it has to look like 1x plus or minus something. That 1, this coefficient, the lead coefficient in the denominator, has to be 1 in order to do synthetic division. If it doesn't look like that, then we've got to do long division. So if it was 2x plus 1, we would have to do long division on it. Okay? But if it's x minus 3, all good. Now, when I do that long division, or when I do that synthetic division, when I divide that out, I am going to get, going to get a remainder. Why? Why will I always have a remainder? Why will I always have a remainder? Nope. What happens if I don't get a remainder? What happens if it ends up being the last number is 0? What does that mean? So if we did this, if we did x minus 2 into something, and I got all the way down here and I got a remainder of 0, or if I'm doing synthetic division, and all the way down here, I get a 0. What does that mean? No. What does that mean? Logie Bear. Means it factors into the problem, right? Which means I did step 1.5 wrong. Because something cancels out then. Okay? So we will always get a remainder there. Okay? And the nice thing about always getting a remainder there is that we are going to instantly drop it. If you don't get a remainder, you've done something wrong. So back yourself up a couple of steps. Okay? But you should get a remainder there, and you're going to just drop it. And your slant asymptote is going to be y equals mx plus b. And this is going to be, oops, let me put that in a different color. And this is going to be what's left from your division. Okay. So, for instance, there's my function, right? Okay. Let's go. Okay. Factor anything you factored out. No, because 3 is not a factor of 8. Okay? 3 doesn't evenly divide into 8. Okay? So, right away, no factors. Degree of the top. What's the degree of the top? Degree of the top is what?
1 bigger than the bottom.
Well, it's 2, right? And the degree of the bottom is 1. So there's a difference of 1 there, right? Okay. So there is no horizontal asymptote. I can't have a horizontal and a slant asymptote. It's one or the other. Okay? So there's no horizontal asymptote, but there is a slant asymptote. So let's find it. Okay? My choices are, I could set x minus 3 equal to 0 and get 3. And then I could synthetically divide into the top, drop, multiply, add, multiply, add, and I get that, right? Then I drop the remainder, and I'm left with y equals 1x plus 10 as my slant asymptote. Okay? Or that's going to be x. That's going to be x squared minus 3x. Change and change. 10x plus 8 plus 10. 10x minus 30. Change and change. 38 is my remainder, right? So I drop this, and here is my slant asymptote. Okay? Either way, the difference is this has to be 1 in order to do synthetic. Okay? All right, let's put it to work in a problem. So, we'll start from scratch. Step number 1 says what? Step 1 says what? Find the domain. Agree with that? Okay. Step number 1.5 says, can I factor the numerator? Can I factor it? Two numbers that multiply to be -3 and add to be 0? Nope, can't do it. Okay? Which means I don't even worry about factoring the denominator because I can't factor anything out of the top, so nothing's going to cancel out, right? So do I have a hole? No, I don't have a hole. Okay? So actually, I can bring this up. Okay? So, my vertical asymptote is what? X equals 2. All right, let's put that on the graph right away. Okay, love it. Step 2. Degree of the numerator.
2.
Degree of the denominator.
1.
So in a horizontal asymptote case, none, right? Okay. So there's no horizontal asymptote, but because they differ by 1, that means I'm going to have a slant asymptote. So I'm going to have step 6 now. I can skip step 5 because nothing canceled out, but I have a step 6 in this problem. Okay. Next step. Third step. Y-intercept. How do I find the y-intercept? I get 3/2. So that gives me a y-intercept 0, 3/2, which is 1.5. Step 4. How do I find the x-intercepts? Boo, how do I find the x-intercepts? Nope, that was number 3. How do I find the x-intercepts? Look at your cheat sheet. Step number 4, x-intercepts. Step what? That's different than plugging in 0. Okay? You know what I mean? Plugging in 0 is what we did in step 3. Making it equal to 0 is different. Okay? All right? Add 3 to both sides. Yes? Okay. What are my x-intercepts? Nope. Nope. Square root of 3, 0. And negative square root of 3, 0. What is the square root of 3? You don't need a calculator for it. Use your brain. What's the square root of 4? 2. So what's the square root of 3? Less than 2, right? But bigger than 1. So I'd probably go somewhere in that 1.5 to 1.7 range. Yes? Did we factor anything out in step number 1.5? So do we have a hole? Okay. Which brings us to step number 6. Our slant asymptote. So our function was f of x equals x squared minus 3 over x minus 2. Can I use synthetic division to divide this problem out? In order to use synthetic division, the denominator has to look like what?
X minus or plus some number.
1x plus or minus some number, right?
Yeah.
Do I have that scenario?
No.
1x minus 2, right? Okay, so I can use synthetic division. So in synthetic division, I take what I'm dividing, I set it equal to 0, and I solve. Then I divide, or whatever I get there, the solution there, I take and I put into my function. The coefficients at the top are 1. Then what? What's my next coefficient? 0. What's my next coefficient? -3. Those placeholder values come back, they're going to come back and bite you. Okay? Drop it like it's hot. Multiply. add, multiply, add. Agree? So that was step number 1 in step 6, or step A, I should say, in step 6. Divide it out. Step B, drop the remainder. Step C, so it's y equals x plus 2. How do I graph the line y equals x plus 2? Y-intercept of 2, slope of 1. So that's up 1, right 1. Okay? So I've got a y-intercept of 2. And a slope of positive 1. So up 1 and right 1, down 1 and left 1. Agree? Now it's an asymptote. So how does it go on the graph? It's a dashed line on the graph. And there's my slant asymptote. Now what's step 6? Now, it's looking funky, I get it. Let's go to step 7. Let's fill in some points, right? Okay. I need 3 points on the left side of my vertical asymptote. Do I already have 3 points on the left side of my vertical asymptote? Yeah, 2 purples, 1 green. Okay. So the left side of my vertical asymptote, the function, if you will, the function looks like that. Do I need to do a T-chart over there? No, already got it, right? Okay. Now let's go over here into this side. Let's do a little T-chart action over here. So, 3. If I put 3 into my function, 3 squared is 9. 9 minus 3 is 6. 3 minus 2 is 1. So that's 6 over 1. 2, 4, and 6. Oops. Four squared. Minus 3 is 13. 4 minus 2. 2, right? That's 6.5. Let's go out to 6. 6 squared is 36. Minus 3 is 33. 6 minus 2 is 4. Roughly 33 divided by 4. 8, a little bit more than 8, right? Okay, 8.25 actually. 1, 2, 3, 4, 5, 6, 7, 8.25 puts me right in there. And there's my function. From that, if we needed to, we could give end and asymptotal behavior. Don't pack up yet. Do not pack up yet. Okay? What would the end behavior be for this one? I'll start you out. As x goes to positive infinity, where does my function go? is going to infinity, where's my function going? So that means it's going up and to the right the whole time, right? So as my function goes to infinity, so the end behavior over here would be as x goes to infinity, my function goes to infinity. Because it's going up and to the right. Somebody's got, oh, Shiki, you gotta pass them back.
Oh.
They're freaking out behind you.
I wouldn't call it
Freaking
freaking out.
out. Okay? Down here, as x is going to negative infinity, my function is going to negative infinity. Okay? Now, on slant asymptote ones, you will never, ever, never have the function in two sections that are right above one another. Okay? Because then it's not a function anymore. Okay? All right? Have a great day.